Hi, let's keep going. Okay, so continuing with the review, we're now up to uh, page 209, exercises 1 and 3. Wait. Okay, no, so now we're up to page 201. So this is going to be 6.4, numbers 1, 3, and 6. Okay, so 6.4 numbers 1, 3, and 6, page 201 to 202. And so let's look at number, number 1. Okay, so for number 1, x is a discrete random variable with probability function f of x given by f of 3 equals 1/3. F of 9 is equal to 2/3. That's our f here. Okay, and we're going to find e of x squared minus 2x plus 1 by first finding e of x and e of x squared and then applying theorem 6.4. Okay, so let's find e of x. E of x is equal to the sum of all possible values of x times f of x. This is equal to 3 times f of 3 plus 9 times f of 9. And so this is equal to 3 times 1/3 plus 9 times 2/3. And so then this will equal 1 plus 6, which is 7. Okay, so that's 7. So e of x is 7. And then e of x squared is the sum over all possible values of x squared f of x. And so this is equal to 3 squared times f of 3 plus 9 squared times f of 9. And so that's equal to 9 times f of 3, which is 1/3, plus 81, 9 squared, which is 81 times f of 9, which is 2/3. And so this is equal to 3 plus 54. 81 over 3 is 27. 27 times 2 is 54. So 3 plus 54 is 57. And so e of x squared is 57. Okay. So now e of x squared minus 2x plus 1 by theorem 6.4 is equal to e of x squared minus 2 times e of x plus e of 1. E of a constant is a constant. And so e of 1 is 1. So e of x squared is 57 minus 2 times e of x, which is 7, plus e of 1, which is 1. And so that's 57 minus 14 plus 1, which is 44. And so the final answer is that e of x squared minus 2x plus 1 is 44. Okay? So that's 6.4. It's one of the problems in 6.4. Let's keep going. Okay, so 6.5.3. So let's look at page 207 to 208, exercises 1 and 5. And so that's on page 207 to 208. Okay, so 207, 208, 1 and 5. Let's do number 5. Okay, so for number 5, the heights of 9 children on a certain baseball team are 4 foot 2 inches, 4 foot 3 inches, 4 foot 4 inches, 4 foot 4 foot 4 inches, 4 foot 5 inches, 4 foot 4 inches, 4 foot 5 inches, 4 foot 5 inches, 4 foot 5 inches, and 4 foot 6 inches, and 4 foot 8 inches respectively. Okay, so 4 foot 2 inches, 3 inches, 4 inches, 4 inches, 5 inches, 5 inches, 5 inches, 6 inches. Okay, so it's 4. Those are the measurements of these 9 players on this baseball team. Find the mean and variance of this set of heights. Okay, so let's find the mean. So the mean, right, is just the sum over all possible values of heights divided by the number, right? So that's the mean. So if you add all these up, right, if you add all these up, your total will be 4, 8, 12, 16, 20, 24, 28, 32, 36 feet. And how many inches? 2, 5, 9, 13, 18, 23, 28, 34, 44 inches. Divided by the total 9. And then, 44 inches. Right? That's what I said. 5, 9, 13, 18, 23, 28, 34, 40, 44 inches. But 44 inches is, there's 12 inches in a foot. So that's 3 additional feet and 8 inches. So this is 39 feet. And then 12, 24, 36, and 8 inches divided by 9. So it's 39 feet, 8 inches divided by 9. And so if you divide 39 feet by 9, you get 4 feet, because it's 36 feet. But then you get a remainder of 3 feet, 8 inches divided by 9. And so 3 feet is 36 inches plus 8, which is 44 inches divided by 9. And so that's 9, 18, 27, 36. So that's 4 inches. 9, 18, 27, 36. Now this is 8 inches over 9. So then you have 8/9 inches. 4 and 8/9 inches. Okay? So the mean, the average height is 4 foot, 4 and 4/8 inches. As a decimal, that would be 4 feet and 4.88 inches. 8/9 is 0.88. So it's the average is 4 feet, 4.88 inches. Okay, so that's the average. So this is the average height. So the average, again, is 4 feet, 4.88 inches. Now, then number the mean, right? The mean is also called the average. Okay, so the average or mean or average. What is that? Okay, so then also want to find the variance of the set of heights. Okay, and so to find, so then the variance, so the variance, sigma squared, which is the variance of x, is e of x squared minus e of x squared, or e squared of x, which is e of x squared. Okay, and so okay, but you could also say it's equal to the sum from I equals 1 to n of the differences of the variations of the mean squared divided by n. And so this is probably the best way to go here. So this is the mean, this is the average. And so if you take each of these heights and you subtract the average and you square it and you divide it by the total number, that will give you the variance. Right, so the variance of x is going to be the is to take each of these and subtract that and square it. And so but you could switch the order. You could go a bar minus ai or ai minus a bar because you're squaring it, and the negative won't matter. So this will be 2.88 inches squared plus 1.88 squared plus 0.88 squared plus another 0.88 squared plus 0.12 squared, and there'll be 3 of those. Plus 1.12 squared plus 3.12 squared, and so that'll be the squares of the sum of the squares of deviations, and you just divide all of them by the total number, which is 9. And so when you compute that numerator and you divide by 9, you get the variance of x. Okay, and so that's the variance of x. And then the e of x, the expected value, is just the sum over all possible values of x times f of x. Well, the possible values of x, you don't have to include all they repeat. So you have x, the possible x values are 4 feet 2 inches, 4 feet 3 inches, 4 feet 4 inches, 4 feet 5 inches, 4 feet 6 inches, and 4 feet 8 inches. Okay, and so you have those 6 possible values of x, and their probabilities would be 1/9. This would have a probability of 1/9. This would have a probability of 1/9. This would have a probability of 2/9. This would have a probability of 3/9. This would have a probability of 1/9, and this would have a probability of 1/9, because there's one of these, one of those, 2 of those, 3 of those, 1 of those, and 1 of those. So you would get a total of 2, 4, 7, 8. Okay. So those would be the probabilities. So you would just take each of these values of x, multiply by those probabilities, and then add them up, and you would get e of x. Okay, and then that would be the average height. That would be the expected value for height. Okay, so that would be e of x and the variance of x. Okay, and so that would be e of x and variance of x of the set of heights, and it would also be just the mean variance of the heights of the children selected. So that'd be number 5 in 6.5.3. And so next one is 6.6. And so the next one is 6.6. And its numbers 1 and 3. Okay, so let's just do number 1. So x is a random variable with e of x is 1. And e of x times x minus 1 is equal to 4. Find the variance of x and the variance of 2 minus 3x. Okay, so the fact that e of x times x minus 1 is 4 means that e of x squared minus x is equal to 4. And that means that e of x squared minus e of x is equal to 4. Well, e of x is 1 here, so that's 1. So that means e of x squared minus 1 is equal to 4. That implies that e of x squared is equal to 5. So e of x squared is equal to 5. And so it says find the variance of x and the variance of 2 minus 3x. So the variance of x is equal to e of x squared minus e of x, e squared of x. E of x squared is 5 minus e of x squared. Well, e of x squared, e of x is 1, so that's minus 1 squared, so 5 minus 1 squared is 4. That's the variance of x. And then the variance of, we want to find the variance of 2 minus 3x. So the variance of 2 minus 3x is equal to, I'm going to write it like this. This is the variance of negative 3x plus 2. And so then that's equal to, by theorem 6.6, that is equal to, theorem 6.6, theorem 6.6 tells us that the variance of ax plus b is equal to a squared times the variance of x. So the thing that you multiply x by, which is negative 3, that's equal to that number squared times the variance of x. Well, that's 9 times the variance of x. And that's equal to, the variance of x is 4, so that's 9 times 4, which is 36. And this is the variance of 2 minus 3x is 36. And again, the variance of x is 4. So we found the variance of x and the variance of 2 minus 3x using theorem 6.6 at the end. And so that's number 1 in 6.6. Okay. Okay, so 6.7, numbers, exercise 4, page 211 and 212, that's number 4. Okay, so Chebyshev's inequality we have for this one. It says, use Chebyshev's inequality to estimate the probability that in any one day, the first business of exercise 3 Okay, let's go back to that because I've been thinking about that for a minute. Let's go to 6.8, number, okay, so in the next video I'll finish this up.